All right, welcome back to physics. Today, what we're going to work on is a quick review of the activities that I've asked you to do in Seesaw, the last few on waves. And my thoughts there are that everybody really sort of wants to know, what does the teacher want me to know? And so by going over these, you'll get an idea of what I hope you'll be able to do on this early part of our unit. All right, so the first activity, remember, going to Seesaw, into physics, and into activities. And our first activity was wave characteristics. I wanted you to use words and pictures. So we have three types of waves we're working on: transverse, longitudinal, and water waves. We haven't really gone in depth yet on transverse longitudinal. So if you want to skip those for the time being, we'll come back and edit those later. On our water wave, we've said, well, characteristics, typically it deals with oceans, but can deal with other large bodies of water, like lakes, even large rivers. We get wind-driven waves in the Columbia River and the Willamette River. So the wind sets up friction, air resistance with the water surface, and creates ripples, which builds into waves. The particles that are in the water actually have an up and down motion and also have a side to side motion. And when we put those two together, what we end up with at the surface is a rather large circular motion of the water particles. As we get deeper, there's less and less motion. And when we get deep enough, then there's no motion based on the wind. Now you have to remember, we're not talking about that the water doesn't move at all. We're talking about no influence from wind-driven waves. We all know that large water bodies, even smaller water bodies, have currents. And so this doesn't have anything to do with currents or tides. We'll talk later about tides, but this is strictly wind-driven waves. So down at the bottom, because I said words and pictures, so I drew a picture, I mentioned some words, and then I said water waves are wind-driven and are at the surface. The particles move up and down as well as side to side. This means that the particles are moving in a circle, okay? All right, the second activity was on tsunamis. And so what I asked you to do here was watch a video. And so I've posted a key to this one. Tsunamis generally caused by earthquakes, volcanoes, and landslides. They are in the open ocean. They may only be about a meter, meter and a half tall, but towards shore they can become very large. They travel incredibly fast. Why are they so destructive near shore? Because the front of the wave slows down to 10 or 20, 30 miles an hour, while the back end is still traveling at 500 miles an hour. And that means it piles up at the shore, resulting in a lot of power, a lot of thrust of water far inland, and a lot of destruction. So how can you be safe? If you hear a tsunami warning, go to higher ground right away. Know your evacuation routes, and keep the Pacific Tsunami Warning Center available on your phone, so that if you hear the sirens or feel an earthquake, you can really quick check that on your phone. All right, the next assignment was to do a little writing to start your essay. So what I said is that, okay, we want to talk about these types of waves, the vocabulary and characteristics. And that's basically what we just went through. So I said, here's some words that you could use. Don't copy exactly what I have, but certainly you can use the gist of what I've done. This essay is about waves. There are three types of waves: water waves, longitudinal, and transverse. And then tell me about each one. Vocabulary, there's four parts to a wave, and then you can go through those. And then the second paragraph is on tsunamis. So tsunamis are large waves caused by earthquakes, volcanoes, and use the information that you found on the video to write a little bit about tsunamis. All right. And then also today we reviewed using water, specifically different types of waves, to create electric power. So I said there were three different types: hydroelectric dams. They are renewable energy. There's no greenhouse gases. But the downside is that there's dams on the river that can block fish migration. Tidal power comes in the ocean where we have tides and does better where there are bigger tides, mostly in the northern latitudes, like Alaska and Great Britain. Um, and the good thing there is, again, that's renewable energy. There's no greenhouse gases, but the devices can impact marine life along the shore. So why not wind-driven waves? That was the question I left for everybody. Why not wind-driven waves? So if you go over today into activities, there's an activity, why wave power isn't working. And go in, watch the video, and then there's three quick questions to answer. So hopefully that will help you. If you had